What's happening, dogs? Mr. Allen here with some graphing of exponential functions, both a parent function and we got some transformations going on in that one. So first thing I'm going to do is I'm going to graph f of x here in a blue marker. And you know what? Why don't I give it a little t-chart action here as well? I'm going to throw one right down here. We could probably use that with some points later on, right? So we got x and then f of x. So when I get some points going on here, let's see. If I plugged in 0, okay, if I plugged in 0, I would end up getting 2 to the 0 power, which is just 1. So 0, 1. Okay. What if I plugged in 1? Well, if I plugged in 1, then I'd get 1 squared is 2, so 2. And then if I plugged in 2, if I were so bold as to plug in 2, 2 squared is 4. So 2, and then we got 4. Right up, 2, 3, 4. Okay, there we go. And then let's even go one negative number here. Negative 1, plug that in, I get what? 1/2? Because negative exponents give me reciprocals. So, okay, here we go. And if I plugged in like negative 2, I get 1/4, so on and so forth. I get some smaller and smaller numbers. Would I ever get to 0, though? If I just keep getting negative exponents, which is just 2 to that power, but flip it, reciprocal, no, I'd never get to 0. So there's actually what's called an asymptote right along there. At, what's the equation of that asymptote? Y equals 0. Nice. So here's my graph of this exponential function, our parent function for this one, which is f of x equals 2 to the x. I'll label this as f of x here. Always good to label your graphs. It's nice. It's a classy move, if you will. All right. How about domain? Domain here. Does it ever stop going left or right? No. So x equals all reals here. How about my range? Does it ever stop going up or down? Well, it keeps going up, and it keeps getting closer to what? 0. Does it ever get there? No. So y is greater than 0. Not equal to, just greater than. All right? So there we go. Parent function. That's about it. Cool? And one other thing about the domain being all real numbers, are there any like no-nos when it comes into plugging numbers into an exponent? No, I can plug whatever I want into an exponent. I can plug in 0. I can plug in positives. I can plug in negatives. There ain't no rules. All right, so that's why the domain is all real numbers. Cool. Awesome. Let's go on to the g of x now. We'll do this one in purple. All right. Now, for this one here, I'm going to need to do some transformations, essentially. Okay? So I'm going to throw in another guy right here. We'll call this g of x. All right? So let's think about what's going to happen here. That negative out in front, okay, that is a reflection. That's a vertical reflection, right? That's going to affect my y value, yes? So that will flip it, okay? It'll flip the graph. So that's going to change my y value. The x plus 3, that's inside the function, that's going to affect my x value because that's a left-right transformation. It's left 3. And then the plus 2 over there, that's going to shift my graph up. 2. So it's also going to affect my y value. So let's do the x's first, shall we? So actually, let's do this. Let me make this a whole nother x and g of x. Hopefully this doesn't get in the way of our graph. We'll find out soon. All right, that's the exciting part of it. So for my x values, if I take that negative 1 and I shift it to the left 3, right, I'd be at negative 4. And if I take 0 and shift it to the left 3, I'd be at negative 3. 1, I'd be at negative 2. 2, I would be at negative 1. Sorry, it's like losing track. Okay, there we go. So transformations, shifted to the left 3. There's my x values. Nothing else is affecting the x value here, right? And again, this is one way of going about graphing an exponential. I think it's nice for the first time. Sometimes they'll even ask you to write new ordered pairs, okay? But you can also just plug and show your way through these things. That's totally fine too. So next up, g of x. What are my transform points going to look like here? So I've got the 1/2 was my original output. It's going to get multiplied by a negative, right? Flipping it to negative 1/2. And then I'm going to add 2. So what's negative 1/2? Negative 1/2 plus 2. That's going to be, this is the same as negative 1/2 plus, what is that, 4 over 2? So that's 3 over 2 or 3/2, 1.5. I'll do 3 over 2, which is 1.5. Okay, cool. That's 1 point done. Could I have gotten that by just plugging in negative 4? Yeah, let's see here. If I did negative 4 plus 3, that's negative 1, right? 2 to the negative first is 1/2 times the negative is negative 1/2 plus 2, 1.5. Works out the exact same. All right, just another way of thinking about it. So next one here, we're going to take our original output of 1. We're going to flip it, so make it negative 1, and then add 2. Negative 1 plus 2. Negative 1 plus 2 is equal to positive 1. Boom, 1. Take the 2. That's our original output. Make it negative because of the negative out front, so it's negative 2. Plus 2, 0. 4 is our next output. Reflect it, becomes negative 4. Plus 2 is negative 2. And just to check one more time here with this guy, if I were to have plugged in negative 1, I'd get negative 1 plus 3 is 2. 2 squared is 4. Negative 4, plus 2, negative 2. Oh, there's a lot of steps there that I'm saying, but hopefully that makes sense there. They may ask you to fill out a little T-chart like this here with your transformed points. But let's go ahead and just plot some stuff and see what the heck this thing even looks like. So if I do negative 4, 1.5, that's an ordered pair, right? Negative 4, oh boy, 1, 2, 3, 4, and then positive 1.5. Okay, we might be all right. Cool, boom. Negative 3, 1, 2, 3, and then I've got myself positive 1. Negative 2, 0, and then negative 1, negative 2. Okay, so looks like it's doing something like that. Is there anything else that I could maybe gather from this? Well, my asymptote here was y equals 0 for the first one. This graph was shifted up 2. So would it make sense that my asymptote is y equals 2? And does it appear, perhaps, that this graph is like getting closer to it over there? It does, right? So that does actually check out there, guys. That's kind of cool. So I'll go ahead and graph this thing. And, you know, fun fact here. Could we figure out maybe our y-intercept? Maybe, you know what? Another time. We'll do it another time. Or we could. Hold on. We could. If I plug in 0 for x, right? 2 cubed is 8. Negative 8, because of the negative. Plus 2 is 6. So plus 2 is negative 6. So 1, 2, 3, 4, 5. Oh, heck yeah, dude. We even had room on the graph. That's exciting, man, right? So if you want to get your y-intercept, you plug in 0 for x, and that'll tell you when it's crossing the y-axis. Kind of nice. Works for any function that has a y-intercept. Let's pop an arrow over here, and then I'll go ahead and label this one as g of x. Now let's talk a little domain and range. Are there any no-nos for my x's? Any no-nos for my domain here? I can plug whatever I want. X equals all reals. Does it ever get high or low? Any kind of cap on this thing? Yeah, it stays below that y equals 2 line, right? So y is less than 2 is my range here. Boom. Dogs. That's fun. Exponentially fun, if you will, right? There we go. So original transformed points. Maybe has to do that. Some information, domain, range, asymptote. They may even ask for the y-intercept. How do we get the y-intercept? I plugged in 0 for x, and we got 6 out. Dang, that's dope. That's awesome. You guys stay dope and awesome. See you later.